Hello dear students. From this video onwards, we will be learning about queue data structure. Actually, queue is a data structure. So if you are asked what queue does, you just have to say queue stores data. I repeat, queue is a data structure. So in one sentence, you can describe queue as queue is used for storing data, period, full stop. But then the method in which it stores data is called first in, first out, FIFO, because whatever is inserted first is always deleted first. You can think of a queue actually of people standing at bus stop. And if this is the first person who has joined the queue, then this should be the first person to come out of the queue and enter the bus. So first in, first out is the strategy used by queue. Let me remind you, stacks use the strategy of last in, first out, whereas queues are first in, first out. Now, queue can be very easily created by using singly linked list. Actually, there are two ways to create the queue, but in this series, we will be learning how to create a linked list which will act as a queue, act as first in, first out. As you all know that a singly linked list contains nodes, and in each node, some data is stored. Yes, singly linked list contains nodes, and every node of this singly linked list stores some data and has a reference or a pointer called next, which can refer to another node of the same queue. Now this diagram, oh, I am so sorry, this is not stack, I am so sorry, queue. This is due to copy paste of these previous videos. Hardly a few things change, isn't it? So forgot to change the stack to queue. Okay, following diagram shows a queue of integers. Now you can see that all these constituents over here are nodes. These are nodes of the queue. And you observe that each node of the queue is storing integer data. This is int data, isn't it? Like 10, 20, 30. And each node is having a pointer called next. And you know that the pointer stores address. So this next is storing address of this big node. Obviously, this next is pointing to the next node. Similarly, this next here in the second node is pointing to next node. Whereas 30 does not have anything to follow, then next pointer stored in the node storing 30 is null. By null, we mean that the pointer is not pointing anywhere. By the way, we have two more pointers here, front and rear. You watch. Now, these are the pointers which will, from externally, they will point to the very first node of the queue and very last node of the queue, as the rear means last. So this is the diagram of the queue. Well, you recall the diagram of stack. If you recall the diagram of stack, let's say that the user enters 10 first in the stack I'm talking about. Forget about queue for some time. Suppose the user enters 10 first, then 20, and then 30. That is push 10, push 20, push 30. Then the next pointer of 30 will point to 20. Next pointer of 20 will point to 10. And next pointer of 10 will be null. And in this stack, there will be only one pointer called top, which will always point to the last node that we have inserted, because last node should become the topmost node. You see the difference between a stack and a queue. Basically, to maintain a stack in the memory, we need only one pointer called top. I'm talking about the header pointer. But to maintain a queue, you observe this is the queue. To maintain this queue, we require two pointers, front and rear. This is obvious because when you think of people standing at the bus stop, and you imagine there is a monitor at the bus stop who will always maintain the references of the first person standing in the queue and the last person standing in the queue. So when the first person gets out of the queue, monitor instantaneously tells this person, which I am underlining, that you are the first person now in the queue. Also, suppose this last person decides to exit the queue. He is really bored of standing in the queue. Then the monitor says this person that you are the last person standing in the queue now. So actually monitor has to keep two counters busy or two pointers busy, front pointer and rear pointer. But in the case of stack, any push or any pop occur only at one end. Please try to understand this sentence. You can see again a stack containing 10, 20, 30, and 30 was the last node. So this becomes top. Everybody knows that. And then next points to 20, which has next, which points to 10, which has next, which is null. Now you tell me, if you are pushing one more value, then one more value will be pushed here after 30. This will be 40, which has next, and it points to 30, and top will get updated to 40. And what if you are popping a value? If you are removing, then removal also will be done at this end only, at the top end. That means any push will further increase top, and any pop will decrease top, isn't it? So any operation is occurring only in one direction, at only at one end in the stack. So in the stack, to maintain a stack, we require hardly one pointer, the header pointer I'm talking about. But to maintain a queue, this is again queue of integers, we require two pointers, front and rear. Why really? Because now just imagine 10, 20, 30 are in the queue. So 30 is the last. Check, 30 is the last. And suppose 40 joins the queue. So where will 40 join? Obviously 40 will join behind 30. What do you say? 40 is the new person. So 40 will stand behind the last person and now claim that I am the last. 40 will say, I have come last in the queue, so I am the last. So this rear pointer will now point to 40. And 30 is next. Observe, this was null. 30 is next will point to 40. Further 40 is next will be null. Just check now. 20 is next points to 30, 30 is next points to 40, and 40 is next is null. And also rear, which was actually pointing to 30, will now point to 40. So at which end is the insertion occurring? Insertion is occurring at rear end. People will join one after the other at the rear end. Whereas if you want to delete a value from this queue, then 10 should get deleted because 10 is the frontmost. So after deleting this value, don't you feel that front should not point here? Come on, this value is deleted. So 20 has to become front. You can see how any deletion is occurring at this end, isn't it? And any insertion is occurring at rear end. So obviously we require two pointers, front and rear, unlike the stack. In stack, we require only one pointer. I hope you have understood the structure of the queue. Now, in the next, you can just check these sentences that I have written. Like ith node of the queue refers to I plus one node of the queue. Obviously, if this is 10 and next, then this ith node points to I plus one node, isn't it? This is I plus one node. And there are two header pointers, first and last. You can call them as front and rear also. That's what we have called them in our code. Okay. So in the coming videos, what we are going to do is we will see the implementation of the queue. Thank you very much.